Alright, so this is a second example of how to use a graphing calculator to identify different characteristics of quadratic equations and use those characteristics to interpret and analyze different real-world situations. So in this problem, we are looking at the median income in dollars of a U.S. household during the years 1995 and 2002. So for this model, I is the income that we are getting, and we are using this quadratic equation, where T is the number of years since 1990. So for 95, we would have T equals 5. For 96, we would have T equals 6. For 2002, we would have T equals 12. So our goal is to graph this function in Desmos and sketch the graph below, but first we need to label the axes. The first one that I'm going to label is my x-axis, or my t-axis, my horizontal. So t, we know, is usually something along the lines of time. It's our x value. So here t is the number of years since 1990. And then we know our y-axis is going to be our output. In this case, it is our median income in dollars, US dollars, whatever. So whenever we graph this, we don't have to have a good picture right now. We just have to have a rough sketch. I know it's going to be an upside down. It's going to be a frowny face parabola because it has a leading coefficient that is negative. And then I can take this information that I have and plug it into Desmos. So we're dealing with negative 133.18 t squared. So instead of doing t squared, I'm going to do x squared because it just makes it easier to graph in Desmos. 3560.5x and then plus 19,170. Alright, so now that my equation looks exactly the same as what I was given in our application, I can see that this is a really narrow parabola, but I can still zoom in on the vertex to figure out what that information is. I could also go over to my settings and change my x-axis to go from 0 to maybe like 20. I could see a lot better what I'm looking at. I could even change my y-axis to go from like 10,000 all the way up to 50,000. And that would give me an even better picture. You can change your axes and you can change your window, things like that with Desmos. It's very accommodating. So after we've graphed this, we need to look at when. So the first question is a when question. So when this starts with when, I'm looking for x equals what? Is the median income 40,000. So median income 40,000 means my y is going to equal 40,000. And I can make this a separate line on Desmos. So open up a new line and write y equals 40,000. And you'll see this line pop up here. Mine's purple, but yours could be any color it chooses. And we have two intersection points. We have one at 8.6 and another one at 18. So we get 2 points. We have this line of 40,000. We have 8.6 comma 40,000. And we have 18.1 40,000. Okay, and this is only valid until 2002. So at 2002, t would equal 12, which means that this point isn't even any good because the t value is 18 here. So there's only one time that it's really good, and that's whenever x equals 8.6. So when x equals 8.6, that would correlate with the year 1998 because it is 8 years after 1990. Estimated median income in 2002, when it says what is the median income, that means y equals what? And in 2002 tells me that x is going to equal 12. So again, you can use Desmos, and you can tell Desmos that you want a line at x equals 12, and it will give you a vertical line with an intersection point. So let's go back over there and do that. So I don't need this y equals anymore. I can change it out to write x equals 12. And you can immediately see mine's going to be a black line, and they intersect at 42,718.08. 42,718.08. So the question was, what is the median? Well, that median income is $42,708, and because we're, 718. Because we are working with money, we can round it to 0.08 cents. Right, and then our last one, question C. What is the estimated maximum income? So again, it says what, which means y equals something. And the maximum is when we're going to be finding the vertex. So my vertex might actually look kind of close to that point that I drew, but we'll see exactly where it is with Desmos. So it's going to be to the right of that. So let's erase that and move it back over here some. The max point. And if I get rid of that x value, I can see that my vertex is 13.367 and 42,967. So 13.367, comma, 42,967. Point 042. So the estimated maximum income would be $42,000, $967.04, because that's the highest point it achieves. And if it were to ask when did we reach that maximum, the answer would be when x equals 13.3, which correlates to the year 2003, because that is 13 years after 1990.